everyone. Just going to leave it about 30 seconds before we get going, just giving everyone a chance to get signed in and get comfortable, and we'll kick it off about 1 minute past the hour. Okay, I think we will get going. So welcome everybody. Welcome to our API Security Excellence webinar, seminar. It's the second in our series. First time around we had quite a theoretical overview, and we'll give a quick recap onto some of the major topics there just so that you can follow along today. Today is going to be a little bit more hands-on. We're going to start working through a specific use case and showcasing some vulnerabilities in design and in code, and how we can apply kind of strong security postures right throughout the API lifecycle. So just before we get going, a little bit of housekeeping. So my name is Kilcommins. I'm Principal API Technical Evangelist here at SmartBear, and delighted to be joined by José Haro Peralta. José, I'd like to say hello to everybody.
Hello, everyone. Thank you for coming. Thank you, Frank, for having me. Very excited about the webinar.
Delighted you're here, José. So today's webinar is being recorded, and all registrants will receive a copy of the recording for their on-demand viewing pleasure. We do encourage as much interaction as possible, so if you do have any questions throughout the session, then please do use the Q&A facility or the chat facility in Zoom. We'll answer them on the fly if applicable, but we will have a dedicated Q&A time towards the end. There will be a few polls popping up now and again as well, just to capture some feedback from you on different topics. And the QR code that you see there on the screen, that is a QR code to José's book all about delivering microservices. So encourage you to check that out a little bit later and purchase a copy. So what we're going to cover today, as I said, initially we're going to give a recap on some of the stuff that we covered in the first session, and we'll put a link to that full session as well as the slideware into the follow-up email that you'll receive tomorrow, or at least this week as well. But in part one, we covered OWASP, we covered the 2020 revamped API risks that have been updated by OWASP. We dived into authentication and authorization, so covering OAuth, OpenID Connect, as well as JOT tokens and how you should sign them. We covered kind of broader security considerations around your API architecture, and then we dived deep into design vulnerabilities and some common pitfalls that both José and myself have experienced firsthand over the years. So we'll be giving a little bit more of a recap on that just before we get going. And then, of course, one of the interesting things is that, we're all doing our best from a security posture perspective, but issues can happen, all of us. So we'll provide some interesting findings that we have uncovered from scanning some well-known APIs that are out there in production. Then we'll be covering security across the API lifecycle. So it shouldn't be just in a single phase just before production deployment. Really, security needs to be baked into all of your API lifecycle if you want to ensure that you can scale a good security posture across multiple teams delivering APIs. And to demonstrate all of this, we'll have a hands-on walkthrough where we'll be talking about a use case, we'll be designing an API to solve for that use case, implementing it, and running through all of the CI workflows for that as well. And then hopefully ample time for Q&A towards the end. So just before we get going, I think a poll will pop up on screen right now, and José has been kind enough to give us the opportunity to raffle off some free copies for his Microservices APIs book, as well as some sign-ups for one of José's courses on building APIs with Python. So participating in the poll will automatically enter you in the draw, and we'll be following up with the winners next week as well. Okay, José, so let's recap on some of the high-level stuff that we covered in the first session, just so everyone can follow along today. So would you like to give everyone an overview on API security and why it matters so much in 2023?
Sure. So API security is all about protecting our APIs, but not only from the point of view of the organization, also from the point of view of the users, to ensure they can enjoy safe experiences with our websites. The thing about APIs, they are not like traditional web services. They expose vulnerabilities and attack vectors nearly through every component of the API. So anywhere from query parameters to path parameters to payloads to anything the user can modify, including headers, can become a vector of attack. So they are very different kinds of beasts, and they require particular consideration. So what we do here from security perspective is we want to prevent those kinds of attacks. We want to ensure the APIs are safe. They're also reliable. They work as expected. They're well designed. And we introduce this concept of security by design. And the idea is to include considerations about API security from the very beginning when we are thinking to model user interactions with the API, when we design the API, but also through the whole life cycle, implementation and operations, how we can do things in a way that they fit within this security framework.
Yeah, exactly. And one of the additional topics that we covered is we dive deep into the revamped OWASP top 10 security risks for APIs, which was refreshed in summer 2023. And of course, this stands for the Open Worldwide Application Security Project, which is like an open source foundation giving security best practices to help us deliver lots of different types of software. And there's a specific known list of vulnerabilities that we should take into consideration for APIs. They're listed here on the right-hand side, and we covered all of these in depth in the first session, so we're not going to cover them right now. But in the hands-on session, we will be diving deeper into a few of these and showing how we can mitigate against them. Then that brought us on to authentication versus authorization, and often there can be a little bit of a misunderstanding as to what the nuances are, Jose. So would you like to summarize it very briefly?
Sure, let's do it. So it's often confusing, right? What's the difference between the two? It's actually quite simple. Authentication is the process of verifying the identity of a user, just verifying that they are who they claim to be, while authorization is verifying that a user has access to what they are requesting from our API. We usually kind of split those processes, the two things, usually following different strategies, but the common one is open authorization. So we have a concept of flows. Users can follow to verify the identity and then obtain access to specific resources. The important thing here is we have different kinds of tokens or elements to identify users and to verify their access. So especially in the context of OpenID Connect, we have the concept of ID tokens. They contain information about the user. They don't fly around between the server and the user. They stay with the client once they've been delivered. And we have the concept of access tokens, which is what we have to use to verify that the user has access to the API. And of course, access to the API is not just to the whole of the API. We will have a concept of scopes and a concept of user roles, functions, and that will tell us what exactly they can do with the API.
Yeah, which is critical. It's not just getting access to the full surface area. Depending on the resources, depending on the operation, you may not have the rights to invoke that specific request.
Exactly.
And then the last kind of big topic that we covered in the first session was talking about common API design vulnerability pitfalls that we've encountered. And we're very much advocates for being able to catch these things as part of the design process and not letting them bleed into later phases of the implementation. And we'll be covering 5 or 6 of these in more depth as we get into the hands-on walk through the design and the code. And looking at this in its kind of totality, there's different lenses and different phases where security approaches and a strong security posture can benefit your overall API program and the individual APIs that form part of that. And of course, the architecture, so that also goes down to kind of the infrastructure of where you're hosting and standing up these APIs. You know, are they in a private network? If they're in the cloud, are you putting them behind a web application firewall? Are you leveraging an API gateway to rate limit and throttle access to the API? If there's a database serving information towards those resources and those endpoints, is that in a private network? As Jose covered in one of the slides previously, the whole authentication authorization considerations. Are we using secure tokens? Are we rolling our own OAuth and security implementation? Or, as myself and Jose would very strongly advocate for, are we bringing in an identity provider to provide that rigor and strong, well-proven implementation for us? If we're using keys for signing, are we rotating those keys often? And of course, are we using secure algorithms? And maybe just on that, Jose, what are some of the common algorithms that you see used right now?
Right. So what is important to realize here is that it's all about the signature process. So in the context of especially of JSON Web Tokens, we can use among various different kinds of algorithms. The most common ones are HMAC and RS-256. And in principle, they are equally strong, but the difference is HMAC is symmetric. So we need to use the same secret we use to encrypt the token to decrypt the token. And if it gets leaked, then that's a very bad thing. But it can get leaked because it's what we have to use to verify the tokens. But also the strength of the signature in that case depends on the secret we use to sign the token. So if it is a long sentence or a long token, something like that, it will be secure. Otherwise, it won't be very secure. So what I recommend always is use a pair of keys, RS-256. It not only makes it more difficult to leak the actual key that we use to sign the tokens, because we only need the public key to verify them. You can't do anything with it. But also by design, it is designed to make the signatures a lot more robust without us having to choose a specific secrets.
Yeah, absolutely. Then looking at some of the different phases of the delivery of an API itself, from a design perspective, we're very much, again, advocates for leveraging well-known specifications that are out there. Again, having these opinionated specifications give us a lot of affordance with being able to describe how our API will work. It also really aids the surrounding tooling that we're going to leverage throughout the process of delivering our API, which really improves discoverability, again, of our API. If an API is easily discovered, it's more easy for us to have an opinion with regards to the security rating of the API, etc. If we don't have any way to do that, then it's almost impossible to protect what we can't see. And again, a lot of the vulnerable design pitfalls that we've seen, we'll be demonstrating how we can catch these because we're leveraging specifications to describe the APIs. Coming then into the development and test phases, using secure coding practices, using static code analysis, especially looking at kind of the security ratings that are coming out there on the code, is always good. And then making sure that security testing is baked into the testing processes that we're doing, and we're not just leaving that for a penetration testing phase that happens before we launch a new product, for example. And if we apply all of these things, then we can have security by design practices right across the API lifecycle. Jose, would you like to kind of cover what this is in a nutshell?
Sure. So the idea of security by design is to shift left our security concerns so that we are thinking about security from the very beginning of the API journey, from the design stage, even before we start thinking about the API specification itself, from the moment we are thinking about how to model user flows through the API, before we have even we get down into the details of OpenAPI or GraphQL or something like that. What you see in the image as ideation. So aligning the API with the business requirements. And so the idea is not to get lost into security details when we are in this stage, but it is to design our user flows in a way that they are conducted to security, in a way that they can be less likely to be abused by malicious users. And then really API security by design plays a role into every step of the API's development process. So the idea is to approach implementation, deployments, operations, from a security perspective. So using secure patterns, using secure operations with higher observability and things like that. Yeah,
absolutely. And as much as we try to apply all of these things, issues can happen, and they happen to the best of us. So what we've done is we've run a scan on some well-known APIs that are out there in production, and actually APIs that are kind of classified as being good APIs to follow from an examples perspective. But I think some of the findings that Jose will walk us through here now are pretty interesting. So Jose, the first one.
All right. So first of all, to say that this is like Frank said, these things happen to the best of us. So this is not an exercise of name and shame. This is an exercise of looking at what happens in the real world, what are the kind of vulnerabilities we can find, but also trying to understand why these things happen and how we can prevent them. So the first example comes from NatWest. If you're not familiar with it, it's a big bank, I think it's based in the UK. What they've done is they leveraging the initiative of open banking, the requirement actually to engage in open banking, They've launched a big API program. They've done it very well. They created a brand for this, the Bank of APIs. And they've created a few products as part of this program. One of them is Pay It, allows you to manage payments through this API. They are overall very well designed, great APIs, but when we run them through the scans using the same tools you're going to see in this webinar, it's surprising to see how many problems you can find in those APIs. So this is one of the best. We only have around 450 errors. We're going to see a lot more in a moment. But if you look at the report, a lot of the stuff we have is around lack of constraints on user input, things like integers without constraints, strings without constraints, arrays, flexible schemas, and so on and so forth. Next one, GitHub, famous, well known to all of us. Again, wow, good API. A classical example when it comes to complaining about API design, also because it's very big, it's very difficult to figure out what you have to do to accomplish a goal with it. But it is very well designed. But again, it is also an example of a great example of the vulnerabilities we can find out there in the wild. So running this scan, we find nearly 50,000 problems in the API. Anything from lack of rate limiting declared in the specification, maybe there is in the implementation, but it is not part of the design of the specification, and that's being shown here. And also what we said before about lack of constraints on payloads, on input parameters, and flexible schemas, and so on.
Yeah, it is quite a huge API description. Which indeed also took us quite some time to scan the whole thing. Yeah, so actually the amount of errors we're going to find here is also a function of the size of the API. So the bigger the more errors we are likely to find. This one, Yapily, is a big provider of open banking in Europe. It's a fintech, so it's the kind of company that works with money. And so in this kind of sector, we want to be certain that the APIs are very secure. There's no scope for mistake in terms of security. But even here, we find nearly 2,000 errors, security errors in the API specification, and again, related with lack of rate limiting declarations or insecure authentication methods in some endpoints, lack of constraints, and so on and so forth. Yeah, I was just going to say, like, the existence of HTTP basic there on certain endpoints related to a payments API is not something that it's a big no-no, and that's a fintech. You're playing with money. So, but another fintech API. So a lot of them are fintechs. Again, because security is particularly important for them. One of the best, actually, we have around 500 errors, and again, related to lack of constraints on strings, integers. In some cases, we can actually constrain user input in these parameters. Sometimes it's a free search, text, or something like that. But when it's becoming a pattern, it shows up in many instances of the API. That's maybe something to worry about. And finally, Plate, another famous fintech API. In this case, we have a lot more errors, nearly 4,500. And again, related to lack of constraints, integers and strings. And again, when, like in some cases, it might be justified, but when it becomes a pattern, maybe something we have to think about. And if we have 4,500 instances of this, I think they need to think a little bit more about security. Yeah, so again, I think that was just eye-opening. So these are all what we would classify as good, solid APIs, but we're still seeing that security vulnerabilities or issues can bleed into those API designs. And again, that just maybe opens up the willingness of a malicious user to at least attempt to exploit some of those vulnerabilities, because it's also easy for them to scan and see that they exist. I think another poll will be popping up now in the background, again, just to gauge people's feedback on certain areas that they would like to see security addressed throughout their API program. So I'll just leave that there, and it's here on screen just for the benefit of those watching on demand. So we're going to change pace now a little bit, and we're going to kind of move out of the theoretical aspect and what we covered in the first session, and now try and apply it in practice. So to do this, myself and Jose tried to kind of come up with a representative problem and a solution to the problem where we would need to design an API and implement an API. So in this fictitious use case, Jose and I are working for a bookstore chain, and we've been traditionally a bricks and mortar operation, so lots of physical bookstores. But what we've seen is that the footfall to those physical stores has been declining rapidly since the global pandemic. As a solution, what we've decided as a company is that we're going to offer predominantly our full catalog as an online e-com shop. And we're going to apply an API first strategy to do that, because we will have our own bookstore website, but we also want to make our our books catalog available through APIs to other third-party ecosystems, so that we get access to a bigger addressable market. So the first thing that we're going to do is start thinking about how we would design an API to solve for these use cases. And one of the things that we're aware of is that there are lots of pitfalls out there when it comes to API designs, and the scans that we went through a few moments ago showcases some of those issues. And if we have a flawed API design, then it can lead to lots more attack vectors being exposed in our APIs and making their way towards production. So what we'll do now is we will jump to a different window where we can bring up the actual API that we've been designing. So we've been designing an open API description because we're working on a REST-ish or RESTful API to satisfy this problem. So we have an API here using OpenAPI 3.0.3, and we have a certain number of resources and endpoints that are going to provide the functionality needed that we've discussed with the business representatives in our company. So we have a login endpoint. So again, this is what people will use, administrators, if they're adding new books to the catalog, but also for known users who want to come and purchase books. We'll have a registry of sellers that we know and will do business with. We'll have an ability to update user details, retrieve the books catalog, create new book listings, retrieve the details of books, see what orders are in process, initiate new orders for a book, and eventually we will update the order once it's been purchased and the payment has been completed. So what we have here on the left-hand side is the YAML representation of what we're seeing on the Swagger UI rendering on the right. And I'm not getting any issues here from the IDE. So it's kind of giving me positive feedback that we've done a decent job initially crafting this open API description. But within our company, we also have stricter rules that we want to conform to from an API design standards perspective. So we want to make sure that all of our APIs are consistently delivered with each other. So for that, we have some standardization rules. And in this specific instance, we're using Spectral to provide that standardization capability for us. And Spectral is a tool that can be used to look at an open API description, run rules over it, and give us feedback as to whether or not what we've created is conforming with those rules. And each of the outputs that are spat out by that linting process will have different levels of severity. So this is an example. Let me just close the Swagger UI window. So this is an example of Spectral file, and in its most basic form, what I've highlighted here is what we're interested in. So what this is saying is that we're creating a Spectral rule set here, and we're extending on top of the base OpenAPI specification rule set, specifically OpenAPI specification version 3. So what we want to do is, if we're linting or validating an OpenAPI definition against these rule sets, we want to prove that it's a valid OpenAPI description conforming to these rules. Now, we also have the affordance of being opinionated as a company as to what we want our APIs to look like. So as well as the base rules, we also have a number of opinionated rules that kind of determine or set the target for what a good API is for our organization. So we have certain opinions that query parameters should all use camel casing. So we have a rule to validate that that's consistently done across all our APIs. Again, we want to make sure for path segments. So if we have resource identifiers in a path, that they all follow kebab case. And we are, as I said earlier, we're building a RESTful API. So we want to make sure that we're leveraging the HTTP semantics and we're using the HTTP verbs appropriately, and we're not putting verbs into the actual resource paths themselves. So again, we have another rule just to ensure that we're not doing that. And again, I'm not going to go into all of the details here, but the goal of Spectral is that it gives our organization, or our fictitious organization in this instance, the ability to be opinionated as to how our APIs should look. And then as an API designer or a developer, I will get feedback as I'm crafting the API to determine, are we conforming to these rules, or do we need to change the API design to match the rules so that we're consistent with every other team. So what I'm going to do now is I'm going to run a scan. So I'm going to run the Spectral rules against this API that we have created here. So to do that, I'm just going to do Spectral lint. I'm going to point to the API in the solution folder, and I'm going to just add on the -d argument here, which is again going to limit the scanning to just errors. So it's not going to pay too much attention to information or warning feedback. So I'm going to run that, and we're going to see if this API is good from our bookstore company perspective. And what we're seeing is that there was no results with a severity of error or higher found. So we have a pretty solid API, at least for a first pass. And we think we have a good API. It's a valid Open API description conforming with Open API 3.0. All of our opinionated rules are also passing. So again, this is consistently how we want an API to look like. So we think we're good. And what we actually do then is we start implementing the code according to this API, and we test it. So we spend a couple of sprints getting all of this work done, and then we commit it into the release cycle to move it up towards production, because we're late October now. We're a bookstore. We're very cognizant that we want to be live before Cyber Monday with our launch. So we push it into the pipeline, and what we can see is that we have our pipeline set up. So we recheck the API against our standards. So we lint the API. That's all passing. So again, we're just validating again that the API is conforming with all of those opinionated rules. We have a phase in here to validate the implementation, and we're using schemathesis for that. And Jose will get a little bit more into detail there in a couple of moments. But what we're doing here is we're validating that the implementation matches the API description. So we're validating that we have all of the endpoints and all of the schemas are defined as we would expect. We then have functional testing that the testers within our team have created, and we've used Ready API for that. So that's our fully fledged API testing tool. So it gives us the ability to do kind of rich end-to-end testing across SOAP services, RESTful services, Kafka, etc. So we have a full kind of functional test suite set up there. We're validating that all of the functionality is passing as we would expect, and we're getting kind of good feedback loops as part of the process. But now we're trying to deploy to production, but we're now seeing at the end that our security tests are failing. So we're getting then feedback directly from the tests that are managed by the information security folks that what we've done has vulnerabilities in there. And if I look at the reports that were kicked out from that security scan, we can see on the specific seller's endpoint, we found 13 issues. And in the user's endpoint, we have 102 issues. And these are covering cross-site scripting vulnerabilities. Let me just zoom in a little bit, that might be small. There's cross-site scripting vulnerabilities as well as JSON boundary scans. And we're finding all of these issues. So here we can see with a put request onto users that we're actually able to embed a script into the name of the user, and that's persisted in the implementation. And that could have big issues for our website if it's just trusting that information as it's coming back from the API, and it may cause something completely unexpected to happen in the user interface. So unfortunately, we're blocked. So after a couple of sprints of effort, we're now prohibited from moving to production because our security scans are failing. So what we're going to consider now, and what myself and Jose will kind of debate on a little bit, is there something extra that we could have done throughout the design? So even though we think our design is pretty solid, Jose, it's passing all of those opinionated rules. It looks good. It's consistent with what we determine as good. But what else could we have maybe done during the design and ideation phases?
Right, so I think we did a good job at aligning the API design with the business requirements, but we didn't think too much about security. So we have unconstrained inputs in the API. We have server-side properties exposed directly to the user. We are reusing some models that are read-only models, and we are using them for input as well. We are representing various operations through the same endpoint. So I think what we could have done at the beginning is actually to be more granular in that analysis of the business requirements, identify different processes, and channel them through different operations in the API. So when we have to retrieve the details of a seller, it's not the same to do it as the seller who's accessing their own details as doing it as a customer or another entity in the API. Then we will have access to this, to less information that maybe is a different endpoint. So those are the kind of considerations we want to take at the beginning of the design process to be in a more robust position in the API design.
Yeah, exactly. So that's what we've decided to do, and that's what we've actually been forced to do because we were blocked from moving to production. So we've decided to kind of mature our approach to security as part of our design flow. And we have some tools at our disposal to kind of help that process. So once we know what we're looking for from a security perspective, we can also leverage the standardization linting that we've shown in Spectral to allow us to do some security scanning as well. So this was the initial Spectral file that we had. And what we've done is now we've just created an additional enhancement to that Spectral file. So everything from line 12 down is exactly the same. But what we've done now is we have extended our rule set to also leverage the OWASP rule set. So granted, this is the 2019 version of the OWASP rule set, but nevertheless, it's a very, very good baseline for us to get feedback during our design process. So, those feedback loops could never be shorter. We don't have to wait for any type of security folks to come in and provide that information to us. We get it right then and there as we're crafting our API. And we've just, for the sake of brevity for the demo, we've just turned off a few of the rules. But again, what I can do now is I can just run the Spectral linting again against the same API, but now I'm just providing a different rule set, which is inclusive of the OWASP scans. And we run this, and I think what we'll be slightly surprised by, at least we were relatively surprised at how many things we didn't get right the first time around, is that we have 100 problems being reported to us with our API design. So even though that design was conforming to what we thought were good, solid, opinionated standards beforehand, we, as you said, Jose, we didn't have a strong enough security posture during that design phase. Is there any of these that you'd like to drill into and for us to explain a little bit more?
Yeah, so I think I want to highlight especially the integers and the strings without boundaries. So an integer without boundaries, especially, for example, in a pagination context, allows malicious users to launch a big integer attack. So request, for example, a million items from the website on a single pagination, putting a lot of pressure on the database. And unconstrained strings can also be leveraged for SQL injection attacks. We also have other things in the API that don't show up here, but things like flexible schemas, exposing server-side properties to user input that we will address as well.
Yeah, absolutely. So I think the good news is that we now have this. We've enhanced our standardization rules to take these into consideration. All teams within our company will be able to benefit from this, and we get the feedback as part of design time. And again, we can validate this as part of CI/CD as well, which we'll showcase a little bit later.
And just to say, this is a great thing actually, because a lot of security issues can be captured at design time.
Yeah, exactly. And what we've actually caught as part of those scans, we've just highlighted them here, and we're going to go into a little bit more detail now on what these specific vulnerabilities are, and we're going to look at the first pass through the API design with the vulnerability in it, and we're going to show the change that we made to the API design to mitigate that from a design perspective. So Jose, do you want to start us off with unrestricted filters?
Sure. So filters, especially in the context of egg collection endpoints, where we have the ability to paginate the collection and filter items. So those are parameters that allow us to do that, filter items according to different criteria. The problem here is they are strings, and they can be integers as well if they are specific pagination parameters. But what they allow us to do as a malicious user, if they are not constrained, especially the string parameters, they allow us to inject SQL injection payloads into the request to the server. If that request ends up in the database, it can have very dramatic consequences. We're going to see some examples of that in the practical part of the code. So what do you think, Frank, we can do here to prevent it?
I think adding the right constraints so that they're not unrestricted, be that regexes or be it enumerations, and then also always making sure that we actually sanitize that input, that we don't just immediately map it and commit it into the persistent layer, that we're making sure that we're leveraging kind of data transfer objects as well where possible, and parameterizing things as well in the various layers of code, I think is important. So looking at on the left-hand side, we have the first iteration of our API, and on the right-hand side, we're showcasing how we have addressed some of these things. So what we can see for the offset parameter, instead of it just being an integer with a default value, so it being kind of unbounded, we have now specified the integer format, and we've also set a minimum and maximum value that are allowed for that offset parameter to ensure that someone can't put in, for example, a negative integer in there, which might not be handled by the server as we would have expected. Same goes for limit. And then Jose, I'll let you take us through the changes that we made for the string format parameter.
Sure. So this is a string. It's also non-required in the payload in the query parameter. But if the user includes this, there are no constraints on this string. So we can put anything we want, any combination of characters, anything that could trigger an error in the server. And if this error isn't captured, it could leak maybe implementation details of our server, or it could even crash the server if we are not handling that exception correctly. But especially it can lead to injection attacks of any kind, SQL injection attacks, command injection attacks, if those statements end up directly in our system, in the database, for example. So what we do to fix this problem in this case is we put an enumeration. So we constrain the values of that string to only 2 possible choices. If that has to evolve in the future, we can always change the API specification. But that way, we don't give the user the freedom to put any kind of free value in this parameter. And this actually is a strategy we can use in most query parameters, string values in our APIs. Like some of them certainly have to be free-form strings. It's like a free-form search for text, but in most cases they are correlated to our database models. So it's not like they can take on an infinite value of infinite number of values. They can only take on so many values, and we can define them as a regex or as an enumeration. And this is a good case for enumeration.
Yeah, exactly. I think at a minimum have some regexes in there that at least enforce the expected pattern. If you're searching for name, then you're not going to be maybe expecting some very strange characters to be put in there.
Like drop table users, yeah.
Exactly, yeah. Okay, the next vulnerability that we found in our first pass through crafting the design was unbounded arrays. So unbounded arrays, they're all about giving malicious users the ability to send payloads with kind of unlimited requests from the server, and this can really cause problems, can cause severe performance issues and unexpected behavior from the server as a result of being put under undue strain by having these unbounded types of arrays defined. So Jose, from a security by design perspective, how would you recommend mitigating this type of issue?
So the strategy we want to use here is to put a maximum number of items in the array. So we don't want to allow users to, if this is a payload coming to the server, surely we are not expecting users to include like 1 million items in the array or something similar. We can constrain that to any number that actually makes sense from a user interaction point of view. And that's how we can address this problem.
Yeah, it's a bit like XML bombing back in the older days. And again, looking at our design, in this instance, on the left-hand side, we had the first pass where we had our books array, and again, it was wide open, no boundaries set on the array. And on the right-hand side, we've resolved that by adding a max items in there. And we've also, again, been a little bit more explicit on the item types and the format of the values that can be sent into that specific property as well. Flexible schemas, Jose, do you want to take us through this one?
Absolutely. So flexible schemas are schemas that allow the presence of additional properties. So when we define a schema, we declare the properties that are supposed to be part of the schema. But the way JSON schema works, and OpenAPI built on top of JSON schema, schemas are not restrictive. So we declare a few properties in the schema, but additional properties can also be present, unless we utilize specific directives to prohibit that. And so what can happen is if we allow the presence of additional properties, users can leverage this to launch, to throw requests to the server that try to override properties they shouldn't have access to. And if that happens, then we are in a situation of mass assignment. So if a user figures out that we have data like customer loyalty points, or like bonus points or access to coupons or things like that, they may be able to overwrite, or even the admin status of a user. They can overwrite those properties in a request by introducing properties that shouldn't be there. And those properties, depending how we handle them in the server, they may end up in the database overriding the data. So how would you do to prevent these things, Frank?
Yeah, I think the different flavors of JSON schema do accommodate for it. So in the flavors used pre-OpenAPI 3.1, we can have additional properties set to false. In 3.1 and beyond with JSON schema 2012 draft, we can also leverage unevaluated properties, which again gives us a little bit more affordance when it comes to kind of composition and more complex schema setups as well. But in general, I think, for this, we also need to think about schema reuse and where schemas will be reused. And there's other patterns that can kind of help us there as well. Kind of command query separation is something that can maybe make it a little bit more manageable for us to be explicit in our designs with regards to having these additional properties turned off, because we can be explicit that this is the specific use case for the schema.
100%.
And again, looking at our first pass through the API on the left versus the changes we made on the right. So for the place order schema, we added in the additional properties false property setting. Again, this is just to make sure that if we are getting an order as part of the post order, that someone isn't trying to set the order status, which is a read-only property, as part of the get orders by ID. But if we were reusing the schema there, then someone could inadvertently set the status of the order to be paid, which might have unexpected behavior when it comes to our payment processing API behind the scenes. And at the end of the day, Jose, we want to make money for the bookstore.
Exactly.
Okay, next one up is integer identifiers. So of course, integers are one of the most common ways out there for us identifying resources in a database and for seeding the databases. So they're very popular, very efficient. However, exposing integer identifiers, especially if they're auto-incremental and sequential in nature, can expose the potential for malicious users to launch feature or surface area attacks and potentially get access to resources that they should not have access to because they guessed the ID. So Jose, how should we go about mitigating this type of issue from a design point of view?
Right, so what we want to make sure is we don't expose those integers directly to the user. If we can, in the database layer, if we can use a different type of identifier, something like a UUID. If we can't do that, if we have to stick with sequential integer-based identifiers, maybe because it's a legacy system and it's already set up like that, what we can do is we can use something like a hashing function. It hides or masks the value of the original identifier and expose something else to the user, something that is not directly is correlated, but is not sequential, it's not predictable. And so for the user, it looks like something that is completely opaque.
Yeah, exactly. And again, looking how we updated our API description to take and address this issue. Again, looking at the seller ID parameter here, initially we just had that defined as an integer. What we've done is we've changed that into a string with a UUID format. And then how we actually manifest that to the user is an implementation concern. But again, the identifier is now opaque from a user perspective, as Jose mentioned. Now, one of the things that we also noticed, Jose, when we were going through some of the security findings was another one of the OWASP top 10 vulnerabilities that had leaked in, broken object property level authorization. And do you want to cover this one?
Sure. So every API has a concept of server-side properties or read-only properties. Things like identifiers, the timestamp when an object was created or when it was updated. Also things like customer loyalty points, the status of a payment. And these are bits of information that we want to maybe the user can read, can have access to this information as a read-only property, but certainly we don't want users to be able to modify those properties. Now, there are situations in which those properties can get exposed to the user. One of them is if we reuse schemas, the same schema we use to represent a resource in a read-only endpoint. If we use the same schema in the user input endpoint, and this happens in some fintech APIs we've analyzed, we've seen some payment endpoints where you can have access to those properties, the status of the payment. Then you can be in a situation of broken object property level authorization. You may be able to override those properties. Of course, it all depends on how you handle things in the actual implementation. We're going to see a slide for that in a moment. But either via optional properties or via unknown properties, users may be able to send those properties in the request. And what we want to do is to ban those properties from the payload so that the user doesn't get a chance to mess with our data.
Exactly. And what we have here is we have some of the snippets from the code, and Jose will be diving into this in a couple of moments in much more detail. But what we have on the left-hand side here is we're receiving the input from the API client to the API consumer. We're more or less blindly iterating over the information that has come in here, and we're immediately setting that using the set attribute method here, and then committing it into the repository itself. So we're not really sanitizing the information, and we don't have a separate schema for, let's say, retrieving users as well as creating users. And again, this could lead to us inadvertently allowing a client to override what we think is a read-only property. Whereas on the right-hand side here, which is our hardened implementation, and what we can see here is that we're using kind of a DTO type of concept here, where we're explicitly mapping all of the information that's come in to our properties, and as part of that we can apply any validation that's been set within those specific objects to ensure that they're conforming to what we expect. But more importantly, we're ignoring properties that we're not expecting to receive from the user in that specific instance. And once we've mapped what we're expecting, then we commit that. And again, this is in Python, but this can be applied to any specific coding language whatsoever. So before we move into kind of what we have, the changes we've made to the implementation to match the hardened design, I think it's good to just talk a little bit briefly as to what we can do during the implementation and testing and additional documentation phases to harden our security posture. So Jose, do you want to run through this quickly, and then we'll jump into code?
Sure. So the first thing we want to do is to make sure first of all, the design is secure. Like we've done before, we identify those vulnerabilities in the design using a spectral or something similar, and we produce a very secure design from the start. And then what we want to do is ensure that the implementation accurately reflects the implementation. And for that, we use different testing strategies like fuzzy testers, ready API, and tools like that. We also want to use secure implementation patterns, like Frank mentioned in the previous slide, things like data transfer objects. Like we mentioned before, we parameterize all the queries to the database and similar strategies. So that when we combine all of these things, and then of course when we have secure operations as well, but when we combine all of these things in the implementation stage, we put ourselves in a much better position to deliver robust and secure APIs. Would you say something else, Frank, here?
Yeah, I think that's it exactly. You know, I think we can also leverage other things as part of our development practices, like static code analysis, giving us again some additional opinionated feedback on our code from a security perspective. And I think, you know, maintainability also feeds into that to a certain degree. But combining being more aware during the design phase, starting off on a solid footing, carrying that into the implementation and testing phases sets us on the road where we can not be surprised when we're getting additional kind of security scans from, let's say, the central security team. All of this, you know, if you think of modern software development, we need to pivot away from having that central security responsibility, because we want to scale security best practices across hundreds or thousands of APIs across distributed teams. So we need to shift left on these considerations, and then also just making sure that they're baked into the CI/CD processes that we have as well, so that we're all singing off the same hymn sheet, as they say. So what we're going to do now is we're going to jump into the code and look at some of the implementation changes that we did along with the design changes. So we're just going to switch screens here briefly.
All right, so I'm going to share my screen now. And so I'm going to walk you through a few of the implementation details. I'm going to show you a few specific examples of the attacks we can perform against the API. What we have here is the API in the state of the crappy implementation we had before. So we had this crappy specification for the vulnerable API design stage and the corresponding implementation, the one that didn't pass the security tests. And so what we're going to do is, just so that you can see more clearly what those attacks look like and what are the consequences, we're going to relay some of those attacks here, and we're going to see the consequences, and then we're going to fix the code according to the new design. Before we get started with that, just a brief walk through the code. We're preparing a repo for this. You will have access to all of this. It's implemented in Python because I think it's easy to understand for everyone, regardless of the stack you use in your daily job. We are using Fast API, which is a very popular framework for implementing APIs in Python. It's very robust, and it's very simple. What we have is a file here, api.py, with the declarations of the routes, the API paths here, and we have the data access layer is directly here. Obviously not the best practice you want to follow in an actual application, but it keeps things simple in this case. We have the instance of the server here. That's what we're going to use to execute the server, and then we use decorators to declare our API endpoints. We use also our ORM called SQL Alchemy to declare our data models. Those are here in models.py. So those are our database models. We generate and apply the migrations to the database using Alembic, which works very well with SQL Alchemy. All the configuration is here, the migrations as well. And we also have a Docker file here with the setup necessary to manage the dependencies and execute the code. And we have a Docker compose file if you don't have to be worried about managing dependencies yourself. Just for information, we manage dependencies here with Poetry. So if you want to run the code directly from here, instead of using Docker, you just have to do Poetry, install Poetry, the necessary version of Python, which in this case is Python 3.10, Poetry install, Poetry shell, and you're ready to go. So that's the setup of the code. It's very simple. And one thing I want to say is, before even you start changing the code here, the first thing we may want to see is how far the code differs from the actual specification. And we can use tools like fuzzy testers for this purpose. And so a fuzzy tester, something like a schema thesis, is a Python package. It's very popular. What they do is they look at the API design, at the specification, they look at the models, and based on those designs and those models, they design payloads that are valid and invalid payloads. They send them to the server and they see how the server handles them. The expectation is that the server will handle correct payloads, valid payloads correctly, and it will reject invalid payloads just as fine, as opposed to crashing, for example. And so schema thesis can be run in different modes. The most simple test is a dry run. It will simply check that the API endpoints are available. You can do a baseline check, just making sure that the server isn't crashing when we throw these payloads to the server. Or you can do a full-blown test, which is going to check for the correctness of the status code, HTTP headers, and conformance to payloads, to schemas actually, and many more things. So what we have here, I already ran the test because it takes a little while to do, and no reason to wait here to do that. I ran the tests against the secure implementation, so all the tests are passing here. What you get is usually around 1,000 tests for a very small API specification, so you really get a nice battery of tests against the implementation. It's going to test anything like negative values, big integers, nullable values that may cause problems in the database. It's really going to give you a lot of feedback about the resilience of the implementation and the security of it, even beyond the design. So what we would do first of all is we would run this test suite against the implementation, get some feedback, and then iterate over the feedback to fix the implementation. But what we're going to do here, we're going to jump straight into these manual tests that we've designed to showcase very clearly what the API threats look like. So the first test we're going to run is against the list books endpoint. So we have this ability to navigate the book catalog. We can, that's the example we saw before. So we can paginate the results, and we can filter books by ebooks or by printed books. What we're going to do here, because we don't have constraints, this is still the insecure implementation, we're going to set the offset to a negative value. That's going to be passed directly to the database, and it's going to cause some issues. So if we do this here, we get actually a leak error, implementation leak. And that's also because we are running the API in debug mode. So that's the first mistake we are doing here. So we are running in debug. So we are leaking implementation details, but also we are not constraining the offset parameter, and we are not handling it properly. So it's going directly to the database and causing errors. What we want to do is, from the new design, is we want to constrain that value. So we look for the endpoint implementation here. It is an optional integer, and we're going to add constraints here using the fast API notation. So we create a query object. This comes from fast API, and we're going to say that the value cannot be lower than 0. In other words, it has to be equal to 0 or greater than 0, and that's the parameter here. Greater or equal.
We actually have a question in the Q&A exactly for this from Tam Norris. Just how can malicious actor exploit lack of constraints on inser strings, and could a request with a very large or very small value cause the API to crash, and that's exactly what you're demonstrating right now, José.
Exactly right. So this is going to be for the integers, and we're going to see a couple of very nice examples leveraging the free strings as well to launch a couple of injection attacks against the database. So we're going to see how that passes through the API and ends up in the database. We're going to see 2 examples of that. We're going to see also an example of mass assignment with a vulnerable payload. So we do that here, and of course we want to do also, we want to say the value cannot be greater than, let's say, 1,000, something like that. We're going to put the default value of 0 as well. So by constraining input at the level of the API directly on the parameter, and this comes from the design, of course, we throw this request now against the API. We're going to pass the results with JQ to make it easier to read. And now we get this 422 response that is telling us that the parameter value is invalid. It has to be greater or equal than 0. So that's the first step. But we have another mistake here, is that we are not parameterizing the query. So that's how those values end up affecting the database. So we would want to modify this also. And just to showcase how we would do in this case, we say we are going to do a scalars query here, and we do a select statement on the book listing object. And we are going to filter things. We're going to open a new line here. We're going to say, well, book listing. We have a constraint on the loyalty points. Actually, I'm not going to change the query parameter yet because I have another example coming up. So I'll change it later. But so far so good. We were able to crash the server with that request. Let's look at the next example. We're gonna have a SQL injection. So that's why I don't want to change the query so that we can see the SQL injection at play. So what we're going to do here is we're going to write the constraints of the query. If we look at the query statement here, we're selecting from the book listing table. We have a constraint on the loyalty points. This is depending on the user. We will be able to have access to special deals if we have a certain level of loyalty points. We're going to be able to filter by book format if we want to. We apply the offset and the limit. So just to show you what it looks like if we don't have the SQL injection attack, the normal request against the books endpoint, as a normal user, I can access one deal, one book. There are 2 other records on the database here in the book listing table. And you will be able to feed this information into the system directly with a fixtures script that we have included. But we have 3 deals. We only have access to one because of our loyalty points. And what we're going to do is we're going to use SQL injection to bypass those constraints and get access to all the information on the table. So if we run this request, and to explain what it's doing, we are leveraging the format parameter, which is a string. It doesn't have any constraints yet. And we're going to assign it to a SQL injection attack, which in this case is overriding the constraints of the query. So it's closing the quote string at the beginning of the query here. It's going to close that quote string, and it's going to say, of course, it has the commenting out here at the end. It's going to comment out the rest of the query, and it's going to say either these constraints or true. 101, 1 equals 1 is true. Which overrides the previous constraints and gives us access to the whole table. So we do that, and now we have access to the 3 records. So the constraints are gone. And of course, to prevent this, the strategy, the first thing we want to do is to make sure that the user cannot write any kind of value here in the format parameter. We want to have specific constraints. We're going to do that by setting the type of the format to an enumeration. So we have, if we go to the schemas file, which is where we have defined all the schemas of the API, we have an enumeration for book format here. And so if we set the parameter to that value, then the user won't be able to set these to a SQL injection attack anymore. So we set it by default to printed books, for example. We access the string value of this parameter here. If we run the request now, we get a 42 response is invalid because the value of format is not what is expected, either printed or ebook. So we can't run the SQL injection attack anymore. I think I have another example of SQL injection against the same endpoint before I change the query, which is this one. So what we're going to do here is we're going to use a different strategy. So far, we've been able to crash or cause errors in the server. We've been able to access information that we shouldn't have access to. That's broken object level authorization vulnerability right there. What we're going to do is we're going to try to starve the resources of the server by running a query that loads the data and puts the server to sleep for a few seconds. So specifically, the query is this one, where you're going to set format to this statement. Again, we close the quote string of the previous constraint, and we say, and this value equals select this from. We run the sleep function of Postgres for 10 seconds, and that's going to hold the server for 10 seconds. If we run many of these requests simultaneously, we're going to eventually put a lot of pressure on the database. We're going to starve the resources, and we're going to crash the API server. So to run this API query successfully, I'll need to undo the changes we did here to constrain the format parameter. So it's still what it was before, allows us to run the SQL injection attack. We run this, and what is going to happen is it's gonna wait 10 seconds before responding. Right. So we only have access to one record here, but the point here, the purpose of this attack wasn't to obtain more information from the server. It was to crash the server by starving the database from resources. And that's what we're trying to accomplish. If we run many requests of this type, eventually the database will run out of resources and the server won't be able to serve any more requests. So if we put the constraints we had before to constrain the value of format and we run the request again, now we get the right response. The input is not what we expected, is not printed or ebook. It is some random chain of characters that we don't accept. And so the SQL injection doesn't work anymore. Now, the next step we want to do here is to fix the query so that it doesn't accept values just like that. So we're going to say scholars here and select from the book listing table. And we're going to say where, and by the way, we can parameterize queries. Of course, that we can do it here as well. We can parameterize, instead of using string interpolation, we can parameterize queries directly here. But the nice thing of the ORM is it directly parameterizes all the queries. So in the case of simple queries like this one, it makes a lot of sense to just use the ORM. That depending, of course, on your stack and your preferences. But here we would say book listing, the discount has to be -50. And then we're going to put the second constraint, which is the format is going to be the format. And actually, it's going to be like, and we have we need to use the parenthesis, the percent here. Then we say format and percent. And finally, we have the offset and limit with the limit. And we delete everything else. So we do that. And if we run the query again, not this one, of course, but the previous one, this one, the simple query, then we have access to the book. Everything works. But if we try to run the SQL injection attack, of course, it doesn't work. So that's a great way of preventing these issues. There are some questions. Do you think, Frank, we address the questions now or we wait?
I think we can address them all in a couple of moments in the Q&A phase. We don't have much more to get through before we can move on to questions.
Yeah, we are almost done here. So, all right, so we've been able to do a lot of things with the, these are just some simple examples. You will get access to the repo with a lot more examples in the README. We've been able to introduce errors and expected behavior on the server. We've been able to staff the database of resources by introducing sleep functions. We've been able to obtain access to data we shouldn't be able to access. Now what we're going to do is we're going to perform a mass assignment attack. So we have a table user for customers, and we have a record. It's in the fixtures. So if you will send instructions, if you set up the server, you run the fixtures, you will get this. What we include also is a brute force attack script here, which runs against the login endpoint. We have a very simple password here. Of course, an issue here is that the password isn't even encrypted, but again, that's more common than we think. And this is just for illustration to show you how simple it would be to break a password if we have enough resources and computing power. But this is just for a simple illustration. And so we're going to set this to false, because that's the original state of the user. So it's a normal user, it's a non-admin, but we're going to do a mass assignment attack to set this property to true. So this is the user figuring out that our data model has such a property in the database. And because our schema is not restrictive in the user profile update, we can include any additional properties. So we're going to try and set that property in the request like you see here. So we're going to set the name, the avatar URL, the address of the user, card details, loyalty points. That, by the way, is a case of exposing server-side properties to the user. We're not going to address it here, but just so that you see how it looks like this vulnerability, we're going to set also isAdmin to true. We're going to see how that value carries all the way to the database. So we throw the request, we pass with JQ, we get the response back. IsAdmin isn't there. It's a hidden property inside the server. The user just figured out that this property exists. But if we look at the user table now, the isAdmin became true. So the user now has admin rights to perform operations on the server. Now, to prevent that, there are a few things we want to do. So we want to look at the user update profile endpoint here. But the first thing we want to do is to look at the schema. So this schema here is allowing the presence of additional properties. What we want to do is to forbid it. And this is the equivalent of using additional properties and setting it to false in the OpenAPI specification. So if we do this and we throw the same request, now it is forbidden because we don't allow extra properties in the payload. But the second thing we want to do is we want to use a safer pattern here. This is what we saw in the previous slides, where we use a DTO type of strategy here to prevent these data override. So instead of that, we want to be very explicit. So we want to say username equals user details name, user address is user details address, user card details is the details card details, and the avatar URL. That's the details like that, and the loyalty points, because we are still exposing that property accidentally through the API, so we can still set it. But that's what we would do. This, of course, is a simplified implementation of this strategy. You will have normally specific objects or functions to perform the data transfer between different layers of the app. But by doing this, by explicitly transferring properties from one layer of the app to another, we're making sure that unknown properties don't carry through to the database. So that's how we can. So hopefully this gives you an idea of how these attacks work in practice and how bad they can be if users can actually perform those things. Like we mentioned, you see this even in well-established fintech APIs. You can manipulate the state of a payment, for example, through user input. It all depends then on the implementation. So whether we use explicit transfer of data from one layer to the other, or whether we have something to prevent those properties from carrying through different layers of the application. So what we will do is we will continue fixing the implementation, running a schema thesis to make sure it complies with the rest of the specification. Then we raise a pull request, and then we see how the tests execute in the CI. And so, Frank, would you like to show us what happens next?
Sure.
I'll stop sharing.
Great. Thanks, Jose. I will written up my screen again. So again, yeah, we've worked hard. Quick recap: worked hard to fix all of the design vulnerabilities. Worked through those in the implementation as well. Validated again that the implementation is indeed matching the API design. And now we're committing this into our main branch, running our CI process so that we can actually release this towards production. And of course, as part of this deployment process, this is often the last chance to really ensure that we're doing all of the checks and balances from a security and from a functional testing perspective and so on and so forth. So Jose has raised that PR, and what we can see is that we have our build that has run, or our CI flow that has run off the secure implementation. So after we've done our work, and previously where those security tests would have failed, now they've passed. But additionally, we've enhanced our linting to match the OWASP linting as well. We have more robust validation implementation, so again, a more rigorous schema thesis. We've updated our functional tests within Ready API to again cover more of the functional scenarios, making sure that we can validate our implementation from an end-to-end, from a business logic perspective. And we've also ensured that all of the security checks and balances have been done across all of the inputs. So we're able to release to production, which is great. And just to drill briefly into some of the functional tests. So this is Ready API, so it's very easy for the testers that are working with us in the team to take that API description. So as we're working on building out the code in parallel, and again, this is one of the powers that an API first process working on the design description first affords us to then execute different phases in parallel. So we can import that open API description directly into Ready API, get a test suite created on the fly to cover all of the surface area. And then it's just a matter of plugging in the additional business logic checks that we want. And when we have that functional test in there, what we can do is just right click on any of these test cases, and we can do create a security test from it. And again, that will pull in all of the context about that specific endpoint that we want to test. And if I just drill into one of the security tests that I've created here, what we'll be doing is we'll be running a series of tests against the user's user by ID endpoint, running boundary scans, running cross-site scripting scans, the fuzzing scans to see if we can trick the server with different flavors of data, invalid types, SQL injection, HTTP method fuzzing, and JSON boundary scans. And the affordance that we have here is also kind of very robust, so we can have different tear up and tear down strategies. We'll also get information as to what will be validated for. So again, as part of the cross-site scripting check, it will be determining if we can trick the server into exposing any of these technical stack information that we can use to then further exploit the server. And we'll be able to see all of the actual injection values that it's going to send through to each and every of the parameters that are specified within our API. So once all of that was done and was executed as part of our test, what we can see is that just drilling in again into that specific endpoint, but this is applied across all of the endpoints, we can see that we had a total of 1,150 different flavors of security tests run against that input, or against that endpoint, should I say, and no issues were found. So all of our security tests passed. So now we have our linting standards passing. We're proving that our implementation matches the design. We're proving that all of our functional tests pass, and we're also proving that everything is secure from a robustness perspective, and we're good to deploy into production. And what we might follow up on in the next session, Jose, is some of the sessions around production. So once we're in production, then some of the considerations that we need to take into account on production when we have a live API around provisioning, access, scopes, how we operate things, how we will monitor and track usage of the API, and does that conform to expected use of the API? And it was one of the questions that popped up in the Q&A. Should we also have logging and tracing put into the implementation? And yes, of course. And this is really then where it will kind of come out and shine, where we will be able to actively monitor how those APIs are consumed. One of the things that's been worked on in the Open API initiative is the workflow specification, and this will define use case orientated flows through different API endpoints to achieve business outcomes. And I think that also gives us a lot of power from an active monitoring perspective to determine, are we seeing clients consume APIs as we would expect? And if we see unexpected consumption patterns of the API, we can automatically on the fly rate limit or throttle that particular client until we're confident that they're consuming the API as we would expect. But as I think, as we said, Jose, right throughout, what we're trying to get to with this type of approach is move from having centralized security control, because if we really want to scale across APIs, and APIs are now the most common attack vector for all organizations, with regards to the capabilities that they expose to the internet, that we have to be able to shift left on some of these considerations and bake security by design practices into each and every phase of the API lifecycle.
100%. And just to say, it was actually really hard to get, for a smallest API specification, it was quite some work to get all these OWASP tests of Spectral to pass, and then get that reflected in the API specification. So it's not trivial to do this, and that's why we have all these examples we saw before of GitHub, Yaply, Bud, Plate. It's very difficult to tackle, but it's very important as well.
Yeah, absolutely. It's no mean feat. As we saw, we were kind of overwhelmed by the amount of issues we found when we validated our API design. We have to take those into consideration from an implementation perspective. But that's again why it's so critical to have the ability to assert and get very fast feedback on how you're posturing from a security perspective, and then equip the teams to be able to do it in a decentralized way, so that they have that autonomy and they know that the guide rails are in there from a standardization perspective, but also from a CI perspective to make sure that they keep on the straight and narrow with regards to what quantifies the next level of a good API. So I think a final poll will pop up behind the scenes. There's just a summary slide that was up there recapping on some of the things that we will do. But what I would like to do is thank everyone for their attendance, and I do welcome any questions from everyone. You'll find some details for myself and Jose here if you want to connect. Again, a big call out to Jose's book, so if you want to follow the QR code there, and we will be raffling off some copies of that as part of the follow-up communications. If you're interested in the design and the implementation and the automation parts of what we did today, it is available at the repository that I have here. And again, we'll include this repository link in the email that goes out, so everyone will have access. And we do encourage people to engage with us through that repository, and we will make efforts to make it better and tackle the problems that you may have. So I'm going to jump in and look at some of the Q&A or the questions that are out there now, Jose, and see if there's anything that we can answer.
Yeah.
So one of the questions we have here, which I'll ask it to you if you want. Some of these patterns and rules, are they more important for external facing APIs? We think we may have some APIs that expose some of these vulnerabilities, but are all of these as important, more or less on the internal facing side as the external facing side? And would you agree that it's just a good rule to apply these changes regardless of where the API is going to be exposed?
So I would like to hear your opinion as well, but mine is applied regardless, because the distinction between internal and internal is pretty much artificial. It could be a very easy infrastructure mistake to get the API exposed to the public. Actually, a lot of the time, those APIs, even if they are supposed to be internal, they are actually facing the internet. And so regardless of the status of the API, it's good practice to apply these patterns to all of them, because they need to be protected just as well. What do you
Yeah,
say,
I think a solid rule of thumb is deliver every API as if it's going to be externally facing at some point in its life cycle. In general, if we're lifting and shifting to the cloud or we're moving more towards cloud native development, your API by default is external facing, so you have to take additional measures to try and lock it down from the public internet. I've seen firsthand a number of times where there's an over-reliance put on an API gateway, and there's trust that all traffic will be coming in that north-south direction. But you can also get exploited on east-west traffic. So, if something malicious gets into your network, it can go sniffing for endpoints that are there. If your API, it's because it's just back-end internal API, it could be wide open because you might be terminating SSL and or auth might be managed purely at that gateway level, but it's wide open internally, then you're leaving it wide open to an east-west attack vector as well. So I think, treat everything as if it was external facing is the right way to go. Just a follow-up around, are these slides and videos going to be shared? Yes, everything will be shared to all registrants. There were some questions about the roadmap. I'll try and include in that information what is externally facing from a roadmap perspective as well, just to answer any of those questions. There's another question here from Tam on how can you prevent SQL injection attacks on fields that have to be a string, i.e. can't be restricted to an enum. So if it's a string value that is not appropriate to constrain as an enum, what's your recommendation there, Jose?
So first of all, parameterize the query, because that way the SQL the input is treated as a string. It won't be treated as, it won't count as it won't pass as a statement. But then also, if you can, in some way, some API gateways can do that, or some web application firewalls can directly reject any request that includes SQL injection attacks. But the most important, I think, is at the level of implementation, parameterize the queries, make sure and sanitize if you can in some way. Look for those parameters and reject the query, the request maybe. What else do you think, Frank?
Yeah, like it bubbles up a little bit to kind of a zero trust type of approach. So you're not going to trust any consumer of the API, even if it is what you know to be the let's say the front end client. More often than not, APIs will inevitably be exposed to more than one client. So you shouldn't have an over reliant trust. I think even this is interesting when you're injecting or pulling in information from third-party APIs. Again, you shouldn't trust that all of that information is safe, and again, that should be sanitized because malicious injections could come in that way. Maybe that third-party client is managing and parsing and escaping everything perfectly, but when it gets sent over to your implementation, if you're just blindly trusting it, should I say, then that can cause issues. Another question from Daniel. I think I kind of answered this one around should logging be there, and if someone is authenticated and probing your API, wouldn't you want to know this? And yeah, absolutely. That's more on the production side of the house, and the active monitoring and making sure that you have good logging and tracing capabilities that are built in, and anything that's out of the norm shouldn't be aggregated. That should be standing out like a sore thumb. Another question. Go ahead. Anything you'd like to add there?
Just to say, I think if there is a third part of this webinar focused on operations, we can introduce the workflow specification also to show expectations on user flows. Like if it is an e-commerce website and a user goes too quickly from one step to the next and maybe bypasses a step that is supposed to be part of the workflow, that's something that can be captured through this tracing and block the user immediately.
Yeah, that could kind of highlight that it's not an actual user on the other side, and they've set up some form of automation to try and bypass and get access to the actual lower level resources as you would not expect. Another question that we have is, are there any common properties that can be returned in response headers that shouldn't be, i.e. that might reveal information about the architecture or the system? And yeah, I think the answer is yes, there are. I think most technical stacks will expose a certain amount of those types of headers that should be sanitized and should not be returned to a consumer of the API. I think, powered by .NET is a very common one that you see out there. But again, anything that's giving away the underlying implementation details is not of interest to an API consumer. So you should take steps to mitigate that. And I think OWASP, if you look on the OWASP site, I think they have a good list there of headers that should be sanitized from API responses as well. And it's baked into some of the security scans that we have in Ready API too. Okay, I think that's all the questions that I'm seeing popping up right now. As I said, if anyone has follow-up questions, feel free to reach out to either Jose or myself directly. Feel free to register any issues in the GitHub repository if you spot any problems in there or would like to see some additional examples covered. That's something that we'll endeavor to enhance over time. So thank you very much, everyone. We're right on time. Thank you, Jose, very much for participating with us. Always a pleasure to collaborate with you on these things.
Thank you. Thank you so much for inviting me for this, and thank you to everyone for attending.
Great. Thanks, everyone.
Thank you.
Bye-bye.